Hello, how are you doing? And a very warm welcome to a very special live edition of TinyBASIC Computers, coming to you here live on the Wi-Fi Sheep YouTube channel. It's part of our New Year's celebration, New Year's Eve celebration live stream. So in this edition, I want to kind of summarize the year and what we've done so far with the TinyBASIC Computers project, and also to give you a live demonstration of all the latest stuff I've been working on with the project, including the latest colour build. This video is sponsored by PCBWay.com, offering services such as 3D printing, injection moulding, CNC machine tooling, sheet metal fabrication, and of course turnkey PCB manufacturing. Take a look at PCBWay.com/projects and all the amazing things people are creating with PCBWay's wide range of production tools and services. Sign up for your free account today at PCBWay.com. Details and links are in the description. Now, before we go any further, if you're not sure what I'm talking about, TinyBASIC Computers is our own real 8-bit build-it-yourself computer series and project I've been running here on the channel for the last 2 years, and it has been hugely successful. During that time, loads of people all over the world have been able to actually take basic parts and build a real BASIC computer that actually booted in BASIC. And it's been, as I said, a huge success. So much so that recently I actually won an award. And I have it here. It's nothing special, but I've not talked about this yet. So here it is. And this is the SARS, a slightly unfortunate name, I'll explain what that is in a minute, SARS Novice Competition 2022, and first place to Tom. So it's one of these kind of very generic things. Basically, I've got a few photos I can show you actually. So basically, I entered the computer, or one of the TinyBASIC builds, into my local amateur radio club. That's what SARS is. It stands for Salop or Shropshire Amateur Radio Society. And I entered it into the build competition as a novice first time entry. That was the rules of the club competition. And I wasn't sure about entering it because basically most people enter radio, ham radio type things. And I said, well, mine's not. It's not really a ham radio, is it? It's a computer. But the club members and the committee were, oh, no, you must enter it. So, okay. So I entered it and I actually won my category. Admittedly, it was only me and one other person in the category. But again, I'm hugely appreciative of the club members who actually voted for the basic system. Here in the picture, you can actually see two systems. I kind of entered them both together as one lot. So it demonstrates the earlier TinyBASIC build here running on the cabaret tube. And we have next to it the experimental colour build, which was running with its SD card filer support. The only snag with that at the time was that it did keep crashing because there's no RAM to run the BASIC interpreter and SD card support. That was a bit of a... It kept falling over basically, but it ran long enough and had a few bytes of RAM left in it in order to run a program, and it was good enough obviously to impress the people there. Admittedly, they're not really computer people, but hey, that's what it is, and I'll take it. It was a win. I also want to show you this. Now, I've had 2 private education customers for TinyBASIC Computers over the last year, or actually a year and a bit now. And this is the latter, which was the National Museum for Computing, or of Computing rather, at Bletchley Park. And they are now customers of TinyBASIC Computers and have actually bought a sort of kit versions to use as educational workshop material in the museum, which is really, really cool. The National Computer Museum, that's where Colossus and Bomb and a lot of the early British computers, code-breaking computers, are all housed in this building, and they've now got TinyBASIC Computers from Wi-Fi Sheep in the same premises. So here is the very first day it ran, and these are actually the boards. These are what mostly young people, children, actually built. It's a slightly different spec to the one I've shown you on the channel because it had various requirements needed for the museum. And they actually got one of these Philips green screen phosphor monitors out, original sort of 80s, feeding through composite, which is rather cool. And they actually ran one monitor. So the kids built their machine. It came up to the terminal, if you like, the monitor, power supply and the keyboard. And they actually tested them out with a couple of inbuilt programs, which were preloaded into the EEPROM for them. And yeah, it was quite successful. So they're one of 2 customers that have been doing education workshops privately, as most of this pay events actually, using licensed versions of the TinyBASIC system as developed on Wi-Fi Sheep. Now, what I want to do now is show you a live demonstration, if I can, and if this works, of the new or current TinyBASIC color kernel, and show you some of the advancements I've got going on. So behind me, I have an Orange Pi 800 set up. Now, if you're not familiar with the Orange Pi 800 and you're watching this pre-record, then there'll be a card up on screen somewhere now, based with our review of the Orange Pi 800. Basically, it's a Pi 400 clone system. So it's an all-in-one ARM-based system created by Orange Pi, which is one of the Chinese clone companies. And the unit was actually very good. It's so good, I've been able to use it as a development board, and that's what I've got running live, and we're going to switch to set up. So let me just show you what we have here on the desktop. Now, it's running in 4:3 aspect ratio because that's what the monitor behind me runs at. So that's why you're seeing it as a square box as opposed to a widescreen. Let's show you what's on the screen then. So over on this side, I've got the Jone IDE. Now, bear in mind, if you're running this on Raspberry Pi 400 with the Debian Linux Raspberry Pi OS build, that will work perfectly fine. You can do pretty much what I'm doing here. You don't need the 800 to do this. It just works quite well on the 800. So this is the Jone IDE. It comes preloaded on Raspbian. You do need to install it manually for the Orange Pi 800. This is the stock Orange Pi 800 OS. It's not Orange Pi OS, because I know some of you have commented you want me to do a video on this, and I've got to get around to that. So this is actually Ubuntu with XFCE desktop. So that's Jone. Then over here, I've got a Minicom terminal window open. And down here, I've got VLC player. And this is showing a live feed from the Raspberry Pi, which is a Pi 1 original that's running the video side of our TinyBASIC system. So it's an Atmega 328p Nano plugged via UART serial into a Pi, which is running a PiGFX terminal. And we're seeing the video output of that via a capture card back to the Orange Pi, which in turn is going through another capture card back to you, and that's what you're seeing. So we've got a capture card looping a capture card, if that makes any sense. Trust me, about 15 minutes prior to coming live on air, none of this was working properly, and I was in a bit of a panic. So let's hope it just holds it together long enough for me to demo this with you. This live video feed here is a little bit delayed. It's a bit choppy frame rate. We're not getting a full 25-30 frames a second through. It runs much smoother in person than you're going to see it on screen. If you're watching this as the pre-record, I'll probably re-record some of the demo bits and you'll see them as a smooth in video as it would be. If you're watching this live, this is going to be a bit choppy. My apologies, but it's not a reflection of the machine's speed. It's just the video capture. So things to show you. If we're running in this mode, which is via USB serial, we type into Minicom here. So if I type a command CLS, you'll see it pops up here as if I'm typing on the actual machine. I'm not. I'm just going through the Orange Pi 800 and I can clear screen. There we go. Cleared screen, no problem. Now, new commands to show you. Well, CLS you knew from last time. That's relatively new. What I have now got are draw commands, which are very similar to the way BBC Basic works. So let me show you. It's not draw for lines, it's actually line. So let's say I wanted to draw a line from this point here in a diagonal all the way down here. Well, I can now do that. I can say line, and I start at 0, 0. And because it's 640 by 480 pixels, I simply say I want to go to 640 by 480. And you can see it draws a line in the terminal space between point A and point B. If I want to color the line, I can do that by calling fcol and giving a color. So I'll say 5. It's probably not the best colour to use. It got something a bit brighter. What's 7? Nope, 7's white. Remember your colours. That's always a good thing to do. F-Cold 3. Come on, something bright for me. Yeah, it'll do. It's not brilliant. It'll do. Right. So if I just retype my line again, 640 by 480. There you go. So it's drawn it the sort of yellow colour. Not the best colour to have picked, but you get the idea. So I can clear my screen again. Let's go F-Col 7. There we go. Right. By the way, B-Col also works. So background colour, B-Col 0. And if I CLS again, there we are. You can get into sort of traditional looking black and white 8-bit computer mode. Whatever you want to do, you can now set that up with our system. You're also now not restricted to typewriting terminal-based layout, which has been a problem with TinyBASIC ever since day one, including the first versions of the colour system. Basically, you couldn't plot anything where you wanted on the screen. You now can. So if I use the command move, now this is text and character base, not pixel base. So if I want to move my cursor, that's the text cursor that is, I can go how many I want to go across. So let's say I want to go 10 characters across and I don't know, 20 lines down. There you go. You can see now that it has now moved. Actually on both Minicom and also on the video terminal itself, we've now moved to the position we wanted to move to, and we could actually type whatever we were going to type there. Obviously that's going to throw an error and it will return back to the next line at 0. So that now allows you to use print and move statements to plot text wherever you want on the screen. It only works with text at the moment. The graphics commands don't need to do this method. They have their own plotting mechanisms, so that's an improvement. We now have the ability to draw rectangles, so I can call up rect command, and this is back to pixel plotting, so I need to tell it where I want to plot on the screen. So if I say 100 by 100, and then I need to give it a size and a width basically. So if I say I want you to be 30 by, let's say 100. There we go. And that will plot a rectangle or square, any dimension or size on the screen wherever you want. And again, you can use F-Col to colour what you want. F-Col 6. And I can call up another rectangle wherever I want to go. So let's say 200, 100, 30, 100. There you go. So we can build up objects and shapes like that in terminal now on this latest build of our TinyBASIC system. Let's take a look at some more advanced programs I've been working on. And this is where the Jone IDE comes in. Now, the nice thing about Jone is that it kind of understands a lot of different programming languages, including BASIC. It doesn't understand everything in this variant of BASIC, because obviously some of the commands are now completely non-standard. But you can see how it does actually understand the formatting for BASIC. And here is a .bas file, which I've got saved as a piece of pre-written code. You could do this on the Pi as well, by the way. You don't need to use the Orange Pi if you don't have or don't want to. It will work on the Raspberry Pi 400 perfectly fine as well. So what I can do is I can actually click copy, making sure I've got a new program. So we'll say new, and we can just check the memory. And that's a full 1023 bytes available. Is I can now paste, and that'll just paste the code straight in. There we go. So we don't have to type line by line into our TinyBASIC computer if we don't want to, which is really, really helpful. So there's the program now in memory, and I'll clear screen again, and we'll just list that again. and I should be able to run. Now the frame rate, this is where the frame rate is going to let me down a little bit because that looks a bit clunky. I can assure you it's actually much better on screen in person than what you're seeing. But that is the classic multicolour line draw program. I used to do this on the BBC Micro, still do actually as a quick and simple demo. And I can now do it in relatively similar code in TinyBASIC on our TinyBASIC computer system. All that will do is keep looping and looping and looping drawing lines. But you'll notice how Minicom can't cope with that because it's only a text-based terminal up here. Oh, there we are. I said something was going to fall over, didn't I? There we go. Something has fallen over. Yeah, that's one glitch we've been having, unfortunately, and I'm not entirely sure what it's down to, but something isn't particularly happy, and I keep getting this error. This error is to do with the Pi and PiGFX rather than anything on my TinyBASIC side. But I'll finish off what I was going to say and then we'll come back to that. So it was drawing quite happily down here. But as you can see up here, it's just plotting random numbers until we escape. There we go. And now it's sort of flashing and doesn't quite know what to do with itself because it can't interpret the control code instructions that were being sent through the serial. So it just does its best. But obviously that's where the two serial between the video output when it's working and the terminal work fine. Okay, so that was the color line demo. And let's just show you a couple of things I've been working on. So this is, I spelled it wrong, but it's basically called drive ball. And I don't know how I've managed to spell drive wrong, but I have. So there we go. This is drive ball, and you can see it's a bit of a longer script or program. And again, as before, we can simply copy and we can paste in. There we go. And CLS. Check that's gone in. It has. And run. So this uses the in-key statements. So it is now possible to program or listen to the tapping of a key in TinyBASIC. This wasn't stock to the original code when we started. So if I now hit space, and again, this is going to look very clunky to you, but you can see again how we have a graphics display from the video here, but the actual terminal display has gone a bit mad up here, but again, to be expected. Now, it's now possible, using keys on the keyboard, I can actually move an object around the screen. And that's actually a lot smoother in reality than it is appearing here. Now, this works because we're drawing this object here and we're using that to clear the screen. So if I go outside the object onto the blue desktop here, or the background, you can see how nothing's wiping frame by frame. So any sprite or object that's being moved won't be cleared. It won't redraw properly. The minute we move back over onto this field here, you can see how it's redrawing each time, hence why you're getting a slight flicker. It is a very flickery process at the moment. But basically, this is the beginning of the ability to do on-screen video games. Very simple Space Invader, Pong type things should now be possible in our version of TinyBASIC with the limited basic set that we've got. So you can control graphics, you can control sound. We've already had sound pretty much from the start, and we've now got the ability to actually control and move objects on screen using the keyboard. Oh, one more thing I'll show you actually, done out of order, but while I remember, we'll just clear the screen for that. Is there is actually a command to turn the cursor on and off. So you can see here we've got the flashing cursor, and if I go cur, C-U-R, 0, it actually turns the cursor off. CUR 1 turns it back on as a solid block, and CUR 2 puts it back to the default flashing. So you don't have to have the cursor on the screen now. You can turn that off if you want as part of your program, and that might be useful, especially with some of the sort of live demonstrations of games where if you don't turn it off, the cursor is going to be in vision as you're trying to write your code. Right, let's have a look at probably one of the more advanced programs, Color Strip, which isn't what it sounds. I appreciate the name is a little dodgy, but trust me, it's not. It's perfectly innocent. So we're going to put this new program in. So let's clear the screen and we're going to copy this program out of the Jone IDE. There we go, straight in. Making sure that if you're doing it in this setup, you're actually tapping into Minicom, not into VLC. Okay, so that program is in. We can list again. There we go. Now, hopefully, if we run this, right, there we go. So in this example, I have an object here on screen, and I've got, can't quite see, the definition isn't quite good on the capture card, but I've got left and right brackets, which are being used as arrows, and we can move the object back and forth. Again, you can see how mad Minicom is going as the text interpreter is how it's seeing it versus what we're seeing actually in vision and graphics. Now, the advantage here is that I can actually hit C for color, and I can bring up a little color pop-up menu down here, and I can select a color. So let's say 11. So I'll type 11, hit enter, and then my object will turn the color I've just chosen. And again, I can manipulate and move that object back and forth on the screen. I can change color again. So let's say, oh, I don't know. Let's say 9. So I select 9, it changes the color again. Now you might be thinking, well, that's very trivial stuff, but this is important developments that my system is capable of actually doing this relatively easily in minimal basic. The only issue we're kind of having is that obviously we're still running on the original Atmega 328p chip, and programs like this are pretty much eating almost the full 1K. And as soon as you start putting color statements in, you're eating valuable bytes of RAM. I wanted to do this demonstration not only with a square, but I also wanted a circle that we could actually manipulate and change the radius as well as the color. I simply don't have the RAM to do both in the program, which is really, really annoying because the system would do it if it had the memory. You see, the issue is that I've hit the top end of development of what I can do with 1K of RAM. Now, the Atmega 328p actually has 2K of RAM. In fact, we can actually look that up on a list if I show you this. So this is the current processor as it is at the moment. This is an Atmega 328p as used on the Arduino Nano and Uno. It's an 8-bit AVR CPU clocked to 16 MHz. It has 2K of static RAM. However, only 1K, or just 1 byte shy of 1K, is available for basic programs. It also has a 1K EEPROM flash memory, which we use as storage, which is extremely useful. And it also has a 1K hardware UART serial link, and that's really important. It has to have that UART serial link for us to be able to communicate with other devices, such as what we've been using the Raspberry Pi as our main graphics terminal at the moment with this current color build. But I do feel that although this has been the bread and butter of the project for the past 2 years, we really have hit the top end, and it's now staggering my development of what we can do with the project so far. I need to look for future possibilities, and one of the roads I really want to go down is looking at the Atmega 1284p, which is a much larger 40-pin DIP package microcontroller. It looks identical on the surface in the amount of pins and size to an original 6502 or even an AZ80. It's not pin compatible, obviously. It's very, very different architecture. But it's an 8-bit AVR CPU, so it's the same architecture that we've been using with the Atmega 328p. And it will clock between 16 MHz, which is what we've been running at, or up to 20. So we could run a little bit faster if we wanted to. To be honest with you, 16 MHz is actually perfectly fine. Mainly because you think about it, a lot of 8-bit computers, BBC Micros clocked at 2 MHz, C64, the NTSC version, the North American version was 1 MHz, the PAL European was less than 1 MHz actually, very slow. And although different architecture, the Sinclair ZX Spectrum was about, was it 4 or 8 MHz? but Z80 was a different architecture, so it had to run a bit faster. Anyway, the point I'm trying to make is that 16 to 20 megahertz for an 8-bit computer running a basic interpreter is probably going to be fine. Now, this chip has a very generous 16K of static memory, and I estimate that that would leave at least 12K available for TinyBASIC, which would be more than sufficient, I reckon. The reason it will have less, or there's going to be a bit of memory eaten up, is that I will be wanting to run things like the SD card library. I can run the sound library without trying to pinch memory from it. At the moment, the sound library, although it's only beeps and dots and stuff, it's not running at full capacity because we're borrowing memory to feed the interpreter. So, and it may open some other opportunities to run a couple of other external drivers and things, which we can't do at the moment. So that's my rough estimate, that probably by the time you're running all that, you probably get about 12K. Bearing in mind, of course, that if we do run with an SD card system, we can chain basic files. So you don't have to have all your program loading in one. You could load, let's say, a splash screen, and you could eat the whole 12K in a splash screen, and then you could dump that and go and chain to another piece of code that's the actual game or whatever it is you're doing. So that will be the advantage of having a modern SD card filer system to go with it. This chip also has a very generous 4K EEPROM, so 4K of data could be installed into flash memory, as opposed to just a 1K at the moment on the 328p. And it also has 2 hardware UART serial links. So not just tying up one TX-RX line, it's got 2, which means you could send 2 alternative signals, as well as the USB signal if we've got a JTAG system set up. So that's another possibility and something I want to look into. So this is probably the road I want to go down. Now, the disadvantage with this chip is that it's, as far as I'm aware, not used on any current Arduino boards. Someone might correct me there, but I definitely know the DIP, 40-pin DIP package version, which is what this is, DIP standing for direct insertion pin, is not used on any Arduino board at the moment, which means there's no easy way of me to tell you how to reflash or upload code to this. It gets into the realm of needing to sell these to you, which means doing a kit, which is a possibility, but it moves this project into new territory. At the moment, the TinyBASIC computer system from Wi-Fi Sheep is not an actual kit. I'm not trying to sell you anything. And that's very different to all the other 8-bit kits and platforms out there from YouTubers and influencers and all that at the moment. I'm not selling you anything. This would change it if we went down this road. Now, another option, and we can do this as well, it's not one or the other, we can do this as well, is to use the Raspberry Pi Pico. Now, at the moment, the Pico, the source code for TinyBASIC, does actually compile. I have got the TinyBASIC interpreter, even the color version, running on a Pico. And it runs really well until you try to put any BASIC in it. The minute you put a BASIC program in, the whole thing locks up and crashes. And it's completely unusable, which is so utterly frustrating when single line commands, without putting a number beforehand, work fine. The minute you put commands in or try to list anything, it breaks. I've been talking to my colleague in Australia about this, and he reckoned it might be something to do with the memory mapping. I have been playing with the memory mapping because I got a feeling that it may be trying to override the Pico bootloader, which might be why it's crashing. I've not had any success. Admittedly, I've not had time to look at it properly. Let's just run through this. So the Pico is a 32-bit chip. It's an ARM dual-core CPU clocked up to 133 megahertz. It has the advantage that third-party boards use the same RP2040 CPU. So the actual chip, the Raspberry Pi chip for this microcontroller, the RP2040, is available for other third-party devices. We don't have to use the Raspberry Pi branded Pico units if we can get this to run. Very generous memory, 264K of RAM. That has advantages, but again, talking to my colleague Scott in Australia, and by the way, Scott, if you're watching, Happy New Year to you. He reckons that TinyBASIC interpreter might only see the first 32 or 64K, and that's due to the way of how it indexes and packets RAM. It's designed for a 4K system, you see, so it might not physically be able to see all the top end of RAM. Is that a problem? I don't think it will be. But I think I think most people with this project will probably be quite happy sitting programs inside 16K of RAM. I might be wrong. Now, one slight disadvantage is there's no onboard EEPROM, so there's no way of saving anything to flash memory. But if we've got the RAM to use the SD card system, which this would support, then saving basic programs to fat formatted micro SD card, you're not really going to need the EEPROM, in all honesty. It's only if you're running without the SD card filer system. And it also has 2 hardware UART serial links. So as with the previous chip, there are advantages of being able to have multiple serial links in and out of the chip. This one will also support serial over USB. Most of them do. My thinking is that we can do both. We should do this. The advantage of doing and getting this running on the Pico is that it means that we can carry on with the breadboard building machines. We're not forcing everyone over to a printed circuit board version of the system where you have to solder things together. It will be possible to hopefully use this chip. We'll give everyone the advantages, more power, more RAM. It's technically no longer an 8-bit system. It will now be a 32-bit system, but you wouldn't really know the difference. And it also means that we should be able to offer a file that you can just simply drag and drop and upload onto the Picos without needing to compile anything. Which actually brings me back to another point, is some of you that have been struggling to upload the precompiled hex ROMs for the current versions of TinyBASIC, and that's because there's a few versions of the clone Atmega 328p Nanos floating around that actually aren't exactly binary compatible, and I did a video on this. If for those of you that follow on the channel will know that they did variants and they didn't label them correctly. Basically, you can't upload the files, and the only way to get complete compatibility here is to offer an open source version in the Arduino IDE that you can compile yourself on your system for whatever native chip you're trying to use, and then you can upload. Now, I wasn't keen on doing that originally because it doesn't always work, and it's not awfully difficult to do, but some people are going to struggle and will never get it to work. There's also another issue. Although we started with an open source off-the-shelf TinyBASIC written in C, there were modifications made to it by my colleague Scott in Australia, and that was his intellectual property. So I had permission to use it for mine, but I didn't have permission to share the source. Now, I've spoken with Scott and I've said, look, I really think, especially for those trying to build these, the free build people, we need to offer some kind of open source version that's just source code that you can look at and download yourself. That's our source code with some modifications in it, so people can actually have a quality of life here. And in the most part, he's agreed. So what I'm hoping to do this year at some point is actually to release a open source compilable version of our TinyBASIC. It'll be cut down and a bit limited in some ways, but hopefully it's going to work with the Pi color graphics system, and you'll be able to build those at home, either running on the original Atmega 328p, or if we can get it to work, the Picos. Saying that, if we use the Pico boards, you don't need the source because we can just offer you a compiled hex ROM file, and you can just literally drag and drop that onto your Pico. You don't need a compiler agent, which Xloader was the name of the compiler agent I was looking for. And the thing is about Xloader is it only works on Windows, and that's very limiting if you're on Mac or PC, and I want to try and cut down these limits if I can. So that's where I see us going with the project, and I'll keep you updated with that as we go forward. So I think that's pretty much everything for this version of, or this edition rather, of TinyBASIC computers. This has been part 11 of the series, although we've done a few additional videos around the side. Thank you so much for joining me for this video. If you haven't done so already, please do consider liking and subscribing. If you want more information about where to find the current TinyBASIC build, especially if you want the free build version, it's here on our Facebook page, which you can go to facebook.com/groups/WFS TinyBASIC. And for advanced users, we have the TinyBASIC Toolkit, which can be found over on Patreon. That's patreon.com/Wi-Fi Sheep. And that's for the £2, $3 general downloads tier. and that includes versions of the color ROM and will include versions of the color system you've seen today demonstrated as soon as I've got it patched and working a little bit better. So that's just about it for this edition. As I said, thank you so much for your company if you've been watching me live for this special edition of TinyBASIC Computers or pre-recorded. And I hope to see you real soon right here on the channel. Until next time, bye for now.